Picture this, right now, at this very moment, as you read these words, the universe is getting bigger. Not slowly, not gradually, but at an incomprehensible, mind-shattering pace. Every second, space itself stretches by thousands upon thousands of kilometers in every direction. Galaxies flee from one another like debris scattered by an explosion that never ends. And here's the part that will keep you awake at night. If you ask the simple, innocent question that any child might pose, what is it expanding into? The universe doesn't just refuse to answer, it laughs at the question itself. It contradicts everything we know about expansion. Think about it. Everything that expands into something. A balloon inflates into the air around it. A city sprawls into the countryside beyond its borders. Water spreads across a table, claiming the dry surface inch by inch. This is the iron law of our experience, the unbreakable rule written into every moment of our lives. Expansion means claiming new territory. It means pushing into space that was once empty, making something larger by consuming the void around it. But the universe? The universe doesn't follow these rules. It doesn't expand into anything. It can't. Because there is no anything for it to expand into. There is no beyond. Let that sink in for a moment. No beyond. No outside. No border where the universe ends and something else begins. When cosmologists tell us the universe is expanding, they're not saying it's like a balloon growing larger in a room. They're saying something far stranger. Something that challenges the very foundations of how we understand space, boundaries, and existence itself. They're telling us that space itself is stretching, that the fabric of reality is being pulled taut like a rubber sheet in all directions at once, and yet there's nowhere this stretching is happening into. How can this be? For decades, this paradox haunted scientists. It troubled philosophers. It fascinated anyone who dared to stare into the cosmic abyss and ask the big questions. The old theories tried to make sense of it, wrapping the mystery in mathematics and clever analogies, painting pictures that almost worked, almost satisfied our need for comprehension. They told us to imagine the universe as the surface of a balloon being inflated, where we, the inhabitants, were like ants crawling on that surface, unable to perceive the third dimension. Or they asked us to think of the universe as an infinite sheet stretching in all directions, where there was no edge because infinity has no boundaries. These metaphors were beautiful. They were elegant. They let us sleep at night. But they were incomplete. Because the universe, as we're now discovering, is far stranger than any balloon, any sheet, any geometric model we could devise. The new data flooding in from our telescopes, our satellites, are increasingly sophisticated instruments pointed at the furthest reaches of cosmic space. This data is rewriting everything we thought we knew. It's showing us the expansion of the universe isn't just happening, it's accelerating, speeding up, getting faster with each passing moment, as though some invisible hand is pulling at the very seams of reality with increasing urgency. And nobody knows why. Dark energy, they call it. A placeholder name for something we cannot see, cannot touch, cannot understand. It makes up 70% of everything that exists, yet it remains as mysterious as the question we started with. This invisible force is stretching space, pushing galaxies apart at an ever-increasing rate, and it's doing so without expanding into anything at all. The universe is getting bigger and bigger and bigger still, not by claiming new space, but by creating space itself. Creating it from nothing. This is where our comfortable understanding begins to crumble. This is where the old metaphors break down and leave us grasping at concepts that dance just beyond the reach of human comprehension. Because when we say the universe is expanding, we're not talking about objects moving through space. We're talking about space itself changing, growing, multiplying between every point in existence. The galaxies aren't traveling through space like ships across an ocean. They're standing still while the ocean itself stretches beneath them. Imagine you're standing in a vast room and someone starts pulling the floor apart beneath your feet. You're not moving. You're perfectly stationary. But suddenly, Your friend standing across the room is getting farther away because the floor between you is expanding. New floor is appearing inch by inch, foot by foot, mile by mile. Where is this new floor coming from? It's not coming from anywhere. It's simply being created between you and your friend, spawned from nothing, conjured into existence by forces beyond your understanding. This is what's happening to our universe on the grandest scale imaginable. But wait, if there is no outside, no beyond, no vast emptiness that the universe is expanding into, then what does expansion even mean? This is where language itself begins to fail us. We're using words designed to describe everyday experiences, words like expand and grow and bigger, to discuss something that transcends everyday reality. We're trying to capture infinity with finite vocabulary, attempting to describe the indescribable with tools never meant for the job. The ancient Greeks wrestled with similar paradoxes. Zeno's paradoxes, they called them. Logical puzzles that seemed to prove that motion was impossible, that an arrow could never reach its target, that Achilles could never overtake a turtle. These paradoxes seemed absurd because they contradicted direct experience, yet the logic was airtight. The resolution came centuries later when mathematicians developed new ways of thinking about infinity, about limits, about continuous quantities that could be divided endlessly, yet still summed to finite values. Perhaps we're facing a similar moment now. Perhaps the paradox of cosmic expansion is challenging us to develop entirely new frameworks for understanding reality, new mathematical tools, new conceptual vocabularies that can capture what our current language cannot.
For a century, Einstein's theory of general relativity has been our guide through these cosmic mysteries. It gave us a new way to understand gravity, not as a force pulling objects together, but as a curvature of space-time itself. Mass and energy warp the fabric of the universe, and objects follow the curves created by this warping, like marbles rolling across a bent rubber sheet. This elegant framework revolutionized our understanding of everything from the orbits of planets to the bending of light around stars to the existence of black holes. And it's general relativity that tells us the universe can expand without expanding into anything. Here's how it works, or at least how we've come to understand it. The universe isn't a thing in space. It's not an object sitting in some larger container. The universe is space itself, along with all the matter and energy it contains, and all the time that flows through it. Space, time, matter, energy. They're all woven together into a single unified fabric that we call space-time. And this fabric can stretch, can bend, can curve back on itself in ways that make our three-dimensional intuitions completely inadequate. When we say the universe is expanding, what we mean is that the metric of space-time, the very ruler by which we measure distance, is changing. A meter stick today is measuring something different than a meter stick a billion years ago would have measured, not because the stick changed, but because the underlying fabric of space changed. Distance itself is growing. Think of it like this. Imagine you're on a vast, infinite grid. Every point on this grid has coordinates, and the distance between any 2 points is calculated by a simple formula. Now imagine that as time passes, this formula changes. The numbers stay the same, but the distance they represent grows larger. Point A and point B haven't moved on the grid. Their coordinates are identical, but the physical distance between them has increased because the meaning of distance itself has changed. This is metric expansion. This is what's actually happening when we talk about the universe getting bigger. The coordinates don't change. The galaxies don't move. But the space between them grows because space itself is growing. It's like having a rubber sheet with dots painted on it. When you stretch the sheet, the dots don't slide across the surface. They simply get farther apart as the material between them expands. But this explanation, elegant as it is, still leaves us with that nagging question: if space is being created, where is it coming from? How can you create something from nothing? Doesn't that violate every law of conservation we've ever learned? Here's where the story gets even more mind-bending. In the quantum realm, the realm of the infinitesimally small, particles pop into existence and vanish again constantly. The vacuum of space isn't really empty. It's seething with activity, with virtual particles appearing and disappearing in fractions of a second, borrowing energy from the universe and paying it back before anyone notices. This isn't speculation. It's been measured. The energy of empty space itself has been calculated and verified through experiments. Could this quantum foam, this bubbling cauldron of virtual particles and fleeting energy fluctuations, be the source of cosmic expansion? Could the creation of new space be somehow tied to these quantum processes, happening at scales trillions of times smaller than an atom? Some physicists think so. Others aren't convinced, but the connection is tantalizing, suggesting that the largest scale phenomena in the universe might be intimately linked to the smallest scale processes. And yet, even if we accept that quantum mechanics allows for the creation of space from nothing, we're still left with the philosophical vertigo of contemplating a universe with no outside. Because here's the thing, when we say there's nothing beyond the universe, we don't mean there's empty space beyond it. We mean there's literally nothing. Not darkness, not void, not even the potential for space to exist. The concept of beyond simply doesn't apply. Try to imagine it. Try to picture the universe that is all there is, with no outside, no container, no surrounding void. You can't. Your brain won't let you. Because every time you try to imagine the universe, you automatically place it in some kind of space, some background against which it exists. But that background doesn't exist. There is only the universe. The universe is all of space. And asking what's outside of it is like asking what's north of the North Pole. The analogy breaks down, of course, it always does, because the surface of Earth is finite. You can travel around it and return to where you started. Is the universe like that? Does space curve back on itself so that if you traveled far enough in one direction, you'd eventually return to your starting point? Or is the universe infinite, stretching on forever in all directions, with no edge and no end? We don't know. Both possibilities are equally mind-boggling. If the universe is finite and curved, then it's like living on the surface of an enormous sphere, except the sphere exists in dimensions we can't perceive. If you could somehow step outside the sphere, which you can't because there is no outside, you'd see it as a closed, bounded object. But from inside, from our perspective, there would be no boundary, no edge, just endless space curving back on itself.
If the universe is infinite, then it's even stranger. Infinite space means that everything that can happen does happen somewhere. Every possible arrangement of matter, every possible history, every possible version of you, all of them exist scattered across the infinite expanse. There are infinitely many galaxies, infinitely many stars, infinitely many planets, and they're all getting farther apart as space expands between them. But how can infinity expand? How can you make something that's already infinite bigger? The answer lies in that same concept of metric expansion. The universe doesn't become more infinite. That's meaningless. What changes is the distance between any 2 points. If the universe is infinite, it was infinite at the moment of the Big Bang, and it's infinite now. What's changed is that points that were once close together are now far apart. The infinite has stretched, even though infinity itself hasn't grown. It's like taking an infinite line and multiplying every distance along it by 2. The line is still infinite, it was infinite before and it's infinite after, but now every pair of points is twice as far apart as they were before. The line has expanded without becoming more infinite. Does your head hurt yet? Good. It should, because we're touching the limits of human comprehension here, reaching the boundaries of what our evolved primate brains can grasp. We're creatures who evolved to navigate 3-dimensional space, to track prey across savannas, to remember where we left the berries. We were never meant to understand the nature of cosmic expansion or the topology of space-time, and yet somehow we're doing it, or at least we're trying. The breakthrough came almost a century ago, when a handful of observers pointed their telescopes at distant galaxies and made a discovery that would shake the foundations of cosmology. Edwin Hubble, working at Mount Wilson Observatory in California, measured the light from faraway galaxies and found something extraordinary. The light was stretched, shifted toward the red end of the spectrum, and the farther away a galaxy was, the more its light was shifted. This was the Doppler effect, the same phenomenon that makes an ambulance siren drop in pitch as it speeds away from you. Except these galaxies weren't just moving away, they were racing away at tremendous speeds. And the pattern was clear. The distant the galaxy, the faster it receded. This wasn't random motion. This was systematic. This was a signature of something fundamental happening to space itself. The universe was expanding. At first, the idea seemed absurd. For millennia, humans had assumed the cosmos was eternal and unchanging. Even Einstein, when he developed his equations of general relativity, was so convinced that the universe must be static that he added a fudge factor, a cosmological constant, to keep it from collapsing under its own gravity. When he learned that the universe was actually expanding, he called it his greatest blunder. But was it? Because decades later, that cosmological constant came roaring back. When astronomers in the late 1990s measured the expansion rate of the universe using distant exploding stars as cosmic yardsticks, they expected to find that gravity was slowing the expansion down. After all the matter in the universe attracts all the other matter through gravity. That attractive force should be putting the brakes on cosmic expansion, making it decelerate over time. Instead, they found the opposite. The expansion was speeding up, accelerating, getting faster and faster as the universe aged. This should have been impossible. There was no force in physics that could push the universe apart like this. Gravity pulls. It doesn't push. What could possibly be driving galaxies apart at an ever-increasing rate? Enter dark energy, or rather re-enter the cosmological constant, Einstein's old fudge factor, now rehabilitated and promoted to the most important component of the universe. This mysterious dark energy, whatever it is, seems to be a property of space itself. Every cubic meter of empty space contains a tiny amount of dark energy. And as the universe expands, creating more space, it creates more dark energy. More dark energy means stronger repulsion, which accelerates the expansion, which creates even more space, which contains even more dark energy. It's a feedback loop, a runaway process, and it means the universe is on a one-way journey to an increasingly lonely future. But let's step back. Let's return to our original question with fresh eyes, armed with all this new understanding. If the universe is expanding, but not expanding into anything, what are we really saying about the nature of reality? Are we saying that space itself is real, a tangible thing that can grow and stretch? Or are we saying that space is just a mathematical description, a coordinate system we use to make sense of where things are? This is where physics meets philosophy, where equations brush up against existential questions. Because the truth is, we don't really know what space is. We have equations that describe how it behaves, how it curves and stretches and responds to matter and energy. But what it actually is, whether it's a real physical thing or just a convenient abstraction, that's still an open question. Some physicists think space is emergent, that it arises from something more fundamental. Just as temperature emerges from the motion of molecules, perhaps space emerges from deeper quantum processes we don't yet understand. In this view, asking what the universe is expanding into is the wrong question, because space itself isn't fundamental. It's a derived property, an approximation that works at large scales but breaks down when you look too closely. Other physicists think space is fundamental, that it's woven into the basic structure of reality. In this view, the expansion of the universe is exactly what it seems, the creation of new space, the multiplication of the cosmic fabric, happening continuously and everywhere. This space isn't expanding into anything because it is the arena of existence itself. There's nothing else for it to expand into. Both views are defended by brilliant minds, both are consistent with observations, and both leave us with a sense of wonder and confusion, with the feeling that we're glimpsing something profound but not quite grasping it fully. Consider the horizon. Not the horizon you see when you stand on a beach and look out at the ocean, but the cosmic horizon, the edge of the observable universe. Because of the finite speed of light and the finite age of the universe, there's a limit to how far we can see. Light from beyond a certain distance hasn't had time to reach us yet. That distance defines our cosmic horizon. But here's the strange part. That horizon is expanding. Not because the universe is growing, well, not just because of that, but because with each passing moment, light from more distant regions has time to reach us. Our observable universe is getting bigger. We're seeing more and more of whatever is out there. And yet, because the expansion of space is accelerating, there are galaxies currently visible to us that will eventually disappear beyond our cosmic horizon. The space between us and them is expanding faster than light can cross it. These galaxies will fade, redshift into invisibility, and vanish from our observable universe forever. We will lose sight of them, not because they've been destroyed or hidden, but because the fabric of space has stretched so much that their light can never reach us again. This means the future is lonelier than the past. Civilizations arising billions of years from now will look out at the cosmos and see far fewer galaxies than we do. They'll see a darker sky, a more isolated existence. If they develop cosmology, they'll have fewer clues about the true nature of the universe. They might never discover that space is expanding, might never find evidence of the Big Bang, might spend eternity thinking their small cluster of galaxies is all that exists. We are lucky. We live at a time when the universe is still young enough, still connected enough, that we can see its history written in the sky. We can observe the afterglow of the Big Bang, that faint microwave radiation pervading all of space. We can measure the expansion rate and trace the history back to the beginning. We can see galaxy clusters and superclusters, the great cosmic web of structures spanning billions of light years. But this window is closing, slowly, inexorably. The accelerating expansion is pulling the universe apart, stretching it thin, isolating every galaxy cluster until each becomes an island universe, alone in an expanding void. Is this the ultimate fate of everything? Will the universe expand forever, cooling and darkening until every star has burned out and every black hole has evaporated and nothing remains but an infinite, cold, empty expanse? Or will something else happen? Will dark energy decay? Will the expansion reverse? Will some new physics, some deeper understanding reveal possibilities we haven't yet imagined? We don't know. And that uncertainty is both terrifying and exhilarating, because it means the story isn't over. It means there are still discoveries to be made, still surprises waiting for us in the depths of cosmic space and the equations of fundamental physics. Think about how far we've come. A century ago, we didn't even know other galaxies existed. We thought the Milky Way was the entire universe, a collection of stars floating in an infinite, static void. Then Hubble showed us that those fuzzy patches we'd been calling nebula were actually distant galaxies, each containing hundreds of billions of stars. And they were all moving away from us. The universe got bigger overnight. Not just physically bigger, but conceptually bigger. Our understanding of cosmic scale expanded along with our understanding of cosmic expansion. And it hasn't stopped expanding since then. Today we know the observable universe contains at least 2 trillion galaxies. 2 trillion islands of stars, each one a galaxy in its own right, scattered across a volume so vast that light takes billions of years to cross it. And all of them, every single one, is participating in this cosmic expansion, riding the stretching fabric of space away from every other galaxy. But remember, they're not moving through space. The space between them is growing. This distinction is crucial. It means that galaxies can be receding from us faster than light without violating Einstein's rule that nothing can move through space faster than light. The galaxies aren't moving through space at all. Space is carrying them along, like raisins in an expanding loaf of bread. This is what Hubble discovered. This is what the data shows. From our vantage point, it looks like we're at the center of a great cosmic explosion with everything fleeing from us. But we're not special. Every galaxy sees the same thing. Everyone thinks they're at the center. Because there is no center. The expansion is happening everywhere simultaneously. Or is it? Because here's another mind-bending fact. The expansion isn't actually happening everywhere. It's not happening inside your body, for instance. It's not happening inside the solar system. It's not even happening inside our galaxy. The distances between Earth and the Sun aren't growing. The distances between stars in the Milky Way aren't increasing. Even the distance between our galaxy and our nearest neighbor, Andromeda, isn't increasing. In fact, Andromeda is moving toward us, and in a few billion years, the two galaxies will collide and merge. So what's going on? If space is expanding everywhere, why isn't everything being pulled apart? The answer is that expansion is only winning where nothing else is stronger. Gravity holds the solar system together. The electromagnetic forces in your body hold your atoms together. These forces are strong enough to overcome the gentle stretching of space at these scales. It's only over vast cosmic distances, where gravity becomes too weak to hold things together, that the expansion of space dominates. Think of it like a rubber sheet with marbles on it. If you stretch the sheet slowly, marbles that are glued together stay together. The glue is stronger than the stretching. But marbles that aren't glued, that are only loosely touching, drift apart as the sheet expands. The expansion doesn't overcome strong local interactions, but it does win over weak ones. This is why galaxies themselves don't expand. The gravity holding them together is strong enough to resist the cosmic expansion. But the space between galaxy clusters does expand, because the gravity between clusters is too weak to stop it. The universe is being pulled apart on the largest scales, while remaining intact on smaller ones. But will this always be true? As dark energy continues to drive the acceleration of expansion, will there come a time when the expansion becomes so rapid that it does overcome local forces? Could it eventually tear apart galaxies, solar systems, atoms themselves? Some models predict exactly this, a big rip scenario where the expansion accelerates so dramatically that in the far future, every bound system gets torn apart. First galaxy clusters, then galaxies, then solar systems, then planets, then molecules, then atoms. Eventually, even the fabric of space-time itself might tear apart in this scenario, bringing existence to a catastrophic end. Other models are less apocalyptic. They suggest the expansion will continue forever, but won't accelerate indefinitely. The universe will keep growing, cooling, darkening, but it won't rip itself apart. Everything will just drift farther and farther away, isolated by ever-increasing distances, until the universe becomes a cold, dark, empty place where nothing interesting ever happens again. Neither fate sounds particularly appealing, but they're based on our current understanding, which could be wrong. We've been wrong before. Every major breakthrough in physics has revealed that our previous understanding was incomplete, that there were phenomena we hadn't accounted for, laws we hadn't discovered, possibilities we hadn't imagined. Could there be something beyond dark energy? Some deeper theory that explains not just the acceleration, but why it's accelerating at exactly the rate it is? Because that rate is puzzling. Dark energy is incredibly weak, so weak that its effects are only noticeable over cosmic distances. But why is it exactly weak enough to allow for stars and galaxies and life to form before tearing everything apart? Why isn't it much stronger or much weaker? This is the fine-tuning problem, and it troubles physicists, because the strength of dark energy seems precisely calibrated to allow for a universe with structure with complexity, with observers like us who can wonder about it. Make it stronger, and the universe would have expanded too quickly for galaxies to form. Make it weaker, and maybe the universe would have collapsed back on itself long ago. Is this just luck? Are we living in the one universe out of countless possible universes where the constants happen to be just right for our existence? Or is there some deeper principle at work? Some reason why dark energy has to have the strength it does? The multiverse offers one answer. If there are infinitely many universes, each with different physical constants, then it's inevitable that some of them will have conditions suitable for life. We find ourselves in one of those universes simply because that's the only kind of universe where observers like us can exist. It's a selection effect, like being surprised that you were born in a time and place where humans can survive. Of course you were, because otherwise you wouldn't exist to be surprised. But the multiverse is a controversial idea. It's hard to test, perhaps impossible to test. If other universes are truly separate from ours, if there's no way to observe them or interact with them, then how can we ever know if they exist? Are we doing science at that point, or are we doing metaphysics? Some physicists embrace the multiverse enthusiastically. Others reject it vehemently. The debate rages on, powered by deep questions about the nature of scientific explanation and the limits of what we can know. Meanwhile, the universe continues its relentless expansion, indifferent to our theories and our debates. Space stretches, galaxies recede, dark energy does its mysterious work, and we watch, measure, calculate, trying to piece together the story of how everything came to be and where it's all heading. Let's return once more to the question that started this journey. What is the universe expanding into? By now, you've heard the answer many times, phrased in different ways. The universe isn't expanding into anything. There is no outside. Space itself is growing. The question doesn't make sense because it assumes a perspective we can't have, a viewpoint from outside that doesn't exist. But maybe we can approach it from another angle. Maybe instead of asking what the universe is expanding into, we should ask what expansion means in the absence of an outside. What does it mean for space to grow when there's nothing for it to grow into? Perhaps the answer is that expansion is purely relational. It's not about claiming new territory or pushing into virgin space. It's about the relationships between things changing. The distance between galaxies grows. The wavelength of light stretches. The density of matter decreases. These are all relational properties. They describe how things relate to other things, not absolute positions or sizes. In this view, space isn't a container that the universe occupies. Space is the web of relationships between all the things in the universe. When we say space is expanding, we mean that all these relationships are changing in a coordinated way. Everything is getting farther from everything else, not because things are moving to new locations, but because the very notion of distance is evolving. This is a subtle shift in perspective, but it's profound. It means we should stop thinking of space as a stage on which the cosmic drama unfolds and start thinking of it as part of the drama itself. Space isn't the background, it's a character in the story, one that changes and evolves along with matter and energy and time. And if space is part of the story, then its expansion isn't something that needs an external arena to happen in. It's an internal process, a transformation of the universe from within. The universe is expanding into itself, if you want to put it that way, or rather, it's expanding and creating itself as it goes, defining what space means through the relationships between everything it contains. Does this make sense? Or does it just replace one mystery with another? Because even if we understand expansion as relational, we still have to grapple with the question of where new relations come from. How can the distance between two galaxies increase if neither galaxy has moved? What does it mean for distance to increase without movement? These questions don't have easy answers. They push us to the edge of our conceptual frameworks, to the place where physics and philosophy blend together in a haze of abstraction and wonder. We're trying to understand something that our brains weren't designed to comprehend, using language that evolved to describe everyday objects and events. And yet we persist. We build bigger telescopes. We develop more sophisticated theories. We run computer simulations that track the evolution of billions of simulated galaxies across billions of simulated years. We teach our children about the Big Bang and cosmic expansion, passing down the accumulated wisdom of a century of discovery. Why do we do this? Why do we care about questions that have no practical impact on our daily lives? No bearing on whether we'll eat dinner tonight or find shelter from the storm? Why does the expansion of the universe matter to creatures living on a small rocky planet orbiting an ordinary star in an unremarkable galaxy? Perhaps it's because these questions touch something deep in the human spirit. We are meaning-making creatures. We tell stories about where we came from and where we're going. We look up at the night sky and feel connected to something larger than ourselves. We want to know our place in the cosmos, to understand the grand narrative of which we're a tiny part. The expansion of the universe is part of that narrative. It tells us we live in a dynamic cosmos, one with a history and a future. It tells us that everything is connected, that every galaxy, every star, every atom shares a common origin in that first explosive moment we call the Big Bang. It tells us that the universe is stranger and more wonderful than we could have imagined, that reality exceeds the boundaries of everyday experience. And maybe that's enough. Maybe we don't need to fully understand what the universe is expanding into, or even what expansion really means in a fundamental sense. Maybe the journey of discovery, the process of asking questions and seeking answers, is itself the point. Maybe the universe reveals itself to us gradually, piece by piece, and part of the beauty is that there's always more to discover. Always another layer of mystery beneath the one we just unraveled. Consider what we've learned in just the past few decades. We've measured the age of the universe to exquisite precision, 13.8 billion years. We've mapped the distribution of galaxies across billions of light years, revealing a cosmic web of filaments and voids. We've detected gravitational waves, ripples in space-time itself, caused by colliding black holes and neutron stars. We've found thousands of planets orbiting other stars, expanding our understanding of planetary systems and raising the possibility that life might be common in the universe. Each discovery opens new questions. Each answer leads to deeper mysteries. The more we learn, the more we realize how much we don't know. But this isn't discouraging. It's exhilarating. It means the adventure continues. It means there's still frontiers to explore, still phenomena to observe, still theories to develop. And at the heart of it all is this strange, beautiful, paradoxical fact. The universe is expanding without expanding into anything. Space is growing without growing into someplace new. Distance is increasing without objects moving farther apart. These contradictions aren't bugs in our understanding, they're features of reality itself, clues that the cosmos operates according to principles deeper and stranger than our everyday intuition can grasp. Think about the implications. If the universe can expand without an outside, what else might be possible? Could time exist without a before or after? Could causality work in ways we haven't imagined? Could there be dimensions of reality we haven't perceived, not because we lack the instruments to detect them, but because our minds lacked the categories to conceive of them? These aren't idle speculations. They're serious questions being explored by physicists and philosophers at the cutting edge of human knowledge. And they all stem from taking seriously the lesson of cosmic expansion, that reality is under no obligation to conform to our intuitions, that the universe plays by its own rules, and that those rules are stranger and more wonderful than we ever expected. So where does this leave us? Standing on our small planet, looking up at a sky full of galaxies rushing away from us, trying to make sense of a universe that defies common sense. We've learned that the universe had a beginning, that it's been expanding for billions of years, that it's accelerating toward a future we can only dimly imagine. We've learned that space itself is a dynamical thing, something that can stretch and curve and respond to the matter and energy within it. But we've also learned humility. We've learned that our understanding is always provisional, always subject to revision in light of new evidence. We've learned that the universe is vaster and more complex than we can fully comprehend, that there are mysteries at every scale, from the quantum to the cosmic.
And yet, we've also learned that we can understand more than we thought possible. That creatures like us, evolved to hunt and gather on the African savanna, can nonetheless unravel the secrets of galaxies billions of light years away. That we can trace the history of the universe back to its first moments and forward to its ultimate fate. That we can ask questions about the nature of space and time and existence itself, and sometimes, miraculously, find answers. This is the great gift of science, the discovery that the universe is knowable, at least partially, at least in principle. That by careful observation and clever reasoning, we can figure out how things work. That the cosmos speaks to us through the language of mathematics and physics, and we've learned to understand that language well enough to have meaningful conversations with reality itself. The expansion of the universe without an outside is just one sentence in that conversation. But what a sentence it is! It tells us that reality is non-Euclidean, that space has properties we never suspected, that the universe is a far more interesting place than a simple three-dimensional box containing objects. It tells us that expansion and creation are intertwined, that new space is being born constantly, that the universe is not a static stage but a dynamic participant in its own evolution. And it reminds us that there's always more to learn. Because even though we can describe the expansion mathematically, even though we can measure its rate and predict its future evolution, we still don't understand it fully. We don't know what dark energy really is. We don't know if the expansion will continue forever or eventually reverse. We don't know if there are other universes beyond our own or if ours is all there is. These unanswered questions aren't failures, they're opportunities. They're invitations to the next generation of scientists, the next wave of discoveries, the next chapter in our ongoing dialogue with the cosmos. Every mystery solved reveals new mysteries. Every horizon reached shows another horizon beyond it. The universe keeps expanding, and so does our understanding, though neither quite in the way we expected. Perhaps that's the deepest lesson of all. The universe doesn't expand into something else because it doesn't need to. It is sufficient unto itself, complete in its own being, requiring no external context or container. It simply is. And its isness includes the property of expansion, the continuous creation of space, the eternal unfolding of distances and durations. In a way, this makes the universe more comprehensible, not less. Because if it were expanding into something else, we'd have to explain what that something else is, and where it came from, and what it's expanding into. We'd end up with an infinite regress of containers and contexts, turtles all the way down. But by understanding that the universe is self-contained, that it defines its own spatial relationships without reference to anything external, we actually arrive at a cleaner, more elegant picture. Not an easier picture, Not a more intuitive picture, but a cleaner one. A universe that is its own frame of reference, its own context, its own totality. A universe that expands not by claiming territory from somewhere else, but by elaborating itself, by becoming more spacious, more expansive, more itself. This is what modern cosmology has revealed. A universe of astonishing self-sufficiency, requiring nothing beyond itself to be what it is. And what it is extraordinary. A vast, ancient, dynamic cosmos filled with galaxies and stars and planets and perhaps even other forms of life scattered across incomprehensible distances. A universe that began in a hot, dense state and has been cooling and expanding ever since, driven by forces we're only beginning to understand. The journey from the Big Bang to today has been eventful. In the first fraction of a second, the universe underwent a period of inflation, expanding faster than light, smoothing itself out and setting the stage for everything that would come after. As it cooled, particles formed. First quarks and gluons, then protons and neutrons, then atomic nuclei, then finally atoms as electrons settled into orbit around nuclei. For hundreds of millions of years, the universe was dark, filled with neutral hydrogen and helium, but no stars. Then gravity began to win, pulling gas into ever denser clumps until finally the first stars ignited, blazing forth with nuclear fire and illuminating the cosmos for the first time since the Big Bang's afterglow faded. Those first stars were massive and short-lived. They burned through their fuel in just a few million years, then exploded as supernovae, seeding space with heavier elements, carbon, oxygen, iron, all the materials needed to make planets and people. Their remnants collapsed into black holes or neutron stars, while the gas they enriched formed new generations of stars, each one incorporating more complex chemistry than the last. Galaxies assembled from these stars and the dark matter that surrounded them. They collided and merged, grew and evolved, creating the spectacular structures we see today. Some galaxies became spirals with graceful arms wound around central bulges. Others became elliptical, featureless collections of ancient stars. Still others remained small and irregular, dwarf galaxies orbiting larger companions. Through it all, the expansion continued. The universe kept growing, space kept stretching, galaxies kept moving apart. But the expansion rate wasn't constant. For the first several billion years, it was slowing down, decelerated by the gravitational attraction of all the matter pulling everything together. Then, about 5 or 6 billion years ago, something changed. Dark energy took over. The acceleration began. The universe started expanding faster instead of slower. And it's been accelerating ever since, approaching a future where the expansion rate grows without limit, where every galaxy beyond our local group vanishes beyond the cosmic horizon, where the universe becomes a lonelier and lonelier place. Unless something changes. Unless dark energy isn't constant. Unless there are new physics we haven't discovered yet that will alter this trajectory. We can't rule these possibilities out. The universe has surprised us before. It will likely surprise us again. But based on what we know now, based on the observations and theories we've developed over the past century, the picture is clear. We live in an expanding universe, one that had a beginning and seems to be heading toward a long, slow, cold end. An end where entropy wins, where all the stars burn out, where all the black holes evaporate, where nothing remains but an infinitely large, infinitely empty space with nothing in it except the faintest quantum fluctuations. It's a bleak picture, in some ways, but it's also beautiful. Because it means we're living in the vibrant middle, the era when the universe is rich with stars and galaxies and complexity, We're here during the good part, the chapter of cosmic history when interesting things happen, when life can arise and flourish and wonder about its origins. And we are wondering. We're building telescopes and satellites, writing equations and running simulations, dedicating our lives to understanding where we came from and where we're going. We're part of the universe becoming aware of itself, consciousness emerging from stardust to contemplate the stars. This is perhaps the most astounding fact of all, that the universe, through us, can ask questions about itself. That matter and energy arranged in the specific patterns we call brains and bodies can ponder the nature of space and time and existence itself. That the cosmos has given rise to observers capable of measuring its expansion, tracing its history, imagining its future.
We are the universe wondering what it's expanding into. We are space, asking what it means to grow. We are time, questioning its own flow. The paradoxes we encounter aren't just intellectual puzzles, they're the universe wrestling with its own nature, trying to understand itself through the minds it's created. And maybe that's the answer, or at least part of the answer, to why the universe bothers to exist at all. Maybe existence is its own justification. Maybe the universe doesn't need a reason or a purpose beyond the simple fact that it is, that it exists, that it unfolds according to laws we're gradually learning to read. The expansion without an outside is a metaphor for this. The universe doesn't need external validation or context. It contains all of reality within itself. Everything that exists within the universe. Everything that happens within the framework of space-time. There is no outside, no beyond, no other place where we might find answers or explanations or meaning. We are here, in this universe, subject to its laws and its constraints. And those laws, those constraints, have given rise to stars and planets and life and consciousness. They've created a cosmos rich enough to support complexity, stable enough to allow structures to persist, dynamic enough to evolve and change over time. Is this luck, design, necessity? We don't know. Perhaps we'll never know. Perhaps the deepest questions, why is there something rather than nothing? Why these laws and not others? Why does the universe exist at all? Are beyond the reach of science, matters of metaphysics rather than physics. But even if we can't answer those ultimate questions, we can still ask them. We can still wonder. We can still push at the boundaries of knowledge, extending our understanding a little farther with each generation. We can still look up at the night sky, at those distant galaxies fleeing from us across expanding space, and feel the profound strangeness and beauty of being here, now, in this particular moment of cosmic history. Because this moment is fleeting. In the vast span of cosmic time, the era of stars and galaxies is brief. The universe spent its first few 100 million years in darkness. It will spend its last trillions upon trillions of years in darkness again. The era we inhabit, this narrow window when the universe is lit up with starlight and rich with complexity, represents a tiny fraction of cosmic history. We are privileged to be here now, privileged to live in a universe that's old enough to have formed heavy elements and planets and life, but young enough that we can still see its history written in the sky. Privileged to exist during the brief period when scientific investigation can reveal cosmic truths, when the evidence of the Big Bang hasn't yet faded beyond detection, when other galaxies are still visible in our telescopes. Future civilizations, if any arise in the far future of the universe, won't have these advantages. They'll inhabit a darker, emptier cosmos. They might never discover expansion, never uncover their cosmic origins, never realize that the universe is larger and older and stranger than what they can directly observe.
But we know. We've figured it out. We've put together the pieces of the cosmic puzzle and assembled a picture of overwhelming grandeur and mystery. A picture that includes expansion without an outside, space growing without growing into anything, the continuous creation of distance and volume from the very fabric of reality itself. This is our inheritance, the knowledge passed down from generations of observers and thinkers who refused to accept easy answers, who insisted on following the evidence wherever it led, who were willing to abandon comfortable assumptions in favor of uncomfortable truths. They've given us a universe more strange and more wonderful than anyone could have imagined. And they've given us a question that still resonates, still challenges, still invites us to think more deeply about the nature of existence. If nothing lies beyond the universe, what is it expanding into? The answer is nothing and everything. The universe expands into nothing because there is no nothing for it to expand into. There is only the universe itself, all of space and time and matter and energy containing and creating itself, sufficient unto itself, requiring no external context or container. But it also expands into everything because the expansion is creating new space, new distance, new relationships between all the things that exist. It's expanding into possibilities that didn't exist before, configurations of matter and energy that are only now coming into being as space stretches and cools and evolves. The universe is expanding into its own future, into what it's becoming, into the vast, cold, empty expanse it will eventually be when the last stars burn out and the last black holes evaporate and entropy completes its inexorable work. It's expanding into a state of maximum disorder, maximum emptiness, maximum separation between every point and every other point. But it's not there yet. For now, for this brief cosmic moment, the universe is full of wonders, full of stars being born and dying, galaxies colliding and merging, planets forming and evolving, full of complexity and structure, and, at least on one planet orbiting one star in one galaxy, full of life, full of creatures who can look up and wonder, who can measure and calculate and theorize, who can piece together the story of cosmic expansion and marvel at its strangeness. We are part of this expansion. The atoms in our bodies were forged in the cores of dying stars, scattered across space by supernova explosions, swept up into new solar systems as the universe continued its relentless growth. We are literally made of star stuff, as a famous scientist once said, and the space between those atoms is participating in the same expansion as the space between galaxies. But we don't notice it. The electromagnetic forces holding our molecules together, the chemical bonds linking our cells, the biological processes maintaining our bodies, these are all strong enough to overcome the gentle tugging of cosmic expansion at our scale. We remain intact, coherent, bound together, even as the universe grows around us. For now. In the far future, if the acceleration of expansion continues unchecked, even these bonds might fail. Even the forces holding matter together might be overcome by the expanding fabric of space. But that's trillions of years away if it happens at all. For the moment, we are safe, protected by the strength of the fundamental forces from the cosmic expansion that nonetheless shapes our universe on the largest scales. This interplay between the forces binding things together and the expansion pulling things apart is one of the great dramas of cosmic evolution. It's what allowed structure to form in the first place. The delicate balance between gravity pulling matter into clumps and expansion trying to smooth everything out. Too much expansion and no galaxies would have formed. Too little and the universe would have collapsed back on itself long ago. We exist because this balance was just right. because expansion was strong enough to prevent immediate collapse, but weak enough to allow gravity to gather matter into stars and galaxies. Because the universe gave us time, billions of years of time, for complex structures to arise, for stars to form and die and scatter their enriched material, for planets to cool and atmospheres to develop and life to emerge and evolve. And now, here we are, products of this cosmic evolution, asking questions about the process that made us. We are the universe examining itself, matter become conscious, stardust contemplating stars. The expansion that we're trying to understand is the same expansion that made our existence possible, that stretched the initial quantum fluctuations into the seeds of galaxies, that gave time for the slow work of stellar nucleosynthesis and biological evolution.
We owe our existence to the expansion of space, and now we're trying to figure out what that expansion means, what it implies about the nature of reality, what it tells us about the deepest structure of existence. We're using brains shaped by evolution for survival on Earth to grapple with phenomena operating on scales of billions of light years and billions of years. And somehow, miraculously, it's working. Not perfectly, not completely. We still don't understand dark energy. We still don't know if the universe is finite or infinite. We still don't know what happened before the Big Bang, or even if before makes sense in that context. We still don't have a complete theory of quantum gravity that would tell us how space and time behave at the very smallest scales. But we've made tremendous progress. We've gone from not knowing other galaxies existed to mapping the distribution of billions of galaxies across cosmic time. We've gone from thinking the universe was static to measuring its expansion rate with exquisite precision. We've gone from speculation to observation, from philosophy to physics, from wonder to knowledge. And the knowledge we've gained only deepens the wonder, because the universe we've discovered is more magnificent, more mysterious, more awe-inspiring than anyone imagined. It's a universe that expands without needing anywhere to expand into, that creates space from nothing, that accelerates into a future we can only dimly perceive. It's a universe that asks us to think beyond our intuitions, to accept truths that seem impossible yet are demonstrably real. It challenges us to expand our own mental horizons, to stretch our understanding in the same way that space itself stretches. It demands that we abandon comfortable assumptions and embrace uncomfortable realities. This is hard. It goes against our instincts. We want the universe to make sense in familiar terms, to behave according to rules we can easily grasp. We want expansion to mean what it means in everyday life, something growing larger in a pre-existing space. We want boundaries and edges and outsides, clear demarcations between what is and what isn't. But the universe doesn't care what we want. It doesn't conform to our preferences or our intuitions. It simply is what it is, obeying laws that existed long before we did and will continue long after we're gone. Our job isn't to make the universe fit our preconceptions. It's to adjust our preconceptions to fit the universe. And when we do, when we set aside our assumptions and really look at what the evidence tells us, we discover something extraordinary. We discovered that reality is far richer, far stranger, far more beautiful than anyone imagined. It's a universe that expands without an outside, that creates itself as it goes, that needs nothing beyond itself to be complete. This completeness, this self-sufficiency of the universe is perhaps the most profound insight of all, because it means we're not missing anything. We're not looking at a partial picture, a universe that's only comprehensible if we understand what's outside it. The universe is the whole picture. It contains everything. It is everything. And that means all the answers we seek are somewhere within it. Maybe not accessible to us, maybe not within our capacity to understand, but they're there, written into the structure of space-time, encoded in the laws of physics, waiting to be discovered by anyone clever enough and persistent enough to find them.
We've already found so much. We've learned that E equals mc squared, that energy and mass are interchangeable. We've learned that gravity is curved space-time, not a force in the traditional sense. We've learned that light is both a wave and a particle, that quantum mechanics governs the behavior of atoms, that the universe had a beginning and is evolving to an end. Each of these discoveries was shocking in its time. Each overturned previous understanding. Each required people to think in new ways, to abandon old certainties, to embrace uncomfortable truths. The expansion of space without an outside is just the latest in a long line of reality checks, reminders that the universe is under no obligation to match our intuitions. But here's the thing. Every time we've accepted one of these uncomfortable truths, it's led to deeper understanding. Every time we've abandoned an old certainty, we've gained something better in return. The universe rewards those who look honestly at the evidence, who follow the logic wherever it leads, who are willing to be wrong if it means getting closer to the truth. And the truth about cosmic expansion is this: space itself is dynamic, changeable, capable of growing and stretching in ways we're only beginning to comprehend. The universe is not a static container, but an active participant in its own evolution. It expands because expansion is part of what it means to be a universe governed by general relativity, with the particular distribution of matter and energy and dark energy that ours has. Could it have been different? Could there be universes that don't expand, or that contract instead, or that remain eternally static? In principle, yes. Einstein's equations allow for various cosmological solutions depending on the matter and energy content. A universe with enough matter and no dark energy would eventually collapse. A universe with different properties might remain unchanging forever. But ours doesn't. Our universe expands, and that expansion is accelerating, driven by mysterious dark energy that permeates all of space. This is the hand we've been dealt, the cosmos we inhabit. And rather than being disappointed that it doesn't match our intuitions or our preferences, we should celebrate the opportunity to understand it, to figure out how it works, to trace its history and predict its future. Because understanding the expansion of the universe isn't just an intellectual exercise. It's a way of connecting with the cosmos, of finding our place in the grand scheme of things. When we look at distant galaxies and measure their recession, we're seeing the universe's history laid out before us. Light from the most distant galaxies has been traveling for billions of years, showing us what those galaxies looked like when the universe was young. We're literally looking back in time, watching the cosmic story unfold in reverse. And when we extrapolate forward, using our understanding of expansion and dark energy, we're glimpsing the future. We're seeing, at least dimly, where this is all heading. We're confronting our cosmic destiny, the ultimate fate of everything we know and everything we are. It's sobering, it's humbling, it's profound. But it's also strangely comforting, because it means we're part of something larger, something that extends far beyond our individual lives or even our civilization's existence. We're part of the universe's story, a small chapter perhaps, but a chapter nonetheless. The atoms that make us up have been on a journey that spans billions of years, from the Big Bang through stellar nucleosynthesis to planetary formation to biological evolution to consciousness. And now those atoms, temporarily organized into the patterns we call humans, are figuring out where they came from. We are stardust that has learned to wonder about stars. We are the universe's way of understanding itself. This isn't just poetic language. It's literally true. The matter and energy that make up our bodies and brains are made of the same stuff as everything else in the cosmos, subject to the same laws, participating in the same expansion. When we contemplate the expansion of space, we're participating in that expansion, not just physically, though the space between our atoms is part of the same fabric that's stretching between galaxies, but intellectually and spiritually. We're expanding our understanding, stretching our conceptual horizons, growing in our comprehension of cosmic truths. This parallel between cosmic expansion and intellectual expansion isn't coincidental. Both involve moving beyond previous limits, exploring new territory, discovering what lies beyond current boundaries. And both raise the same question. Expansion into what? When we expand our understanding, what are we expanding into? New concepts? New frameworks? New ways of thinking?
Just as the universe expands without needing an outside, perhaps our understanding expands without needing a pre-existing framework to expand into. We create new concepts as we need them, new ways of thinking about problems, new mental models that allow us to grasp previously incomprehensible ideas. Our minds, like the universe, are self-expanding systems, capable of growth without requiring external space to grow into. This is the deep symmetry between mind and cosmos. Both are creative, both are self-organizing, both are capable of producing novelty and complexity from simpler origins. The universe began as a hot, dense, uniform state and evolved into the rich tapestry of structure we see today. The mind begins as a simple neural network and develops into the sophisticated thinking apparatus capable of comprehending cosmic expansion. And both processes continue. The universe keeps expanding, keeps evolving, keeps producing new configurations of matter and energy. The mind keeps learning, keeps developing, keeps discovering new truths about reality. Neither has reached an endpoint. Neither has exhausted its possibilities. There's always more expansion to come, more growth to achieve, more mysteries to uncover. So when we ask what the universe is expanding into, maybe we're really asking what we're expanding into. What lies beyond our current understanding? What truths are waiting to be discovered? What aspects of reality remain hidden from us, not because they're fundamentally unknowable, but because we haven't yet developed the concepts and tools needed to grasp them? The answer is the same in both cases: nothing and everything. There's no pre-existing territory of understanding waiting for us to colonize it. There's no repository of truths sitting out there waiting to be discovered. Instead, we create understanding as we go, developing new concepts and frameworks that allow us to make sense of observations and measurements. We expand into the unknown by transforming it into the known, by creating mental maps of previously uncharted territory. This is what science does. It expands human understanding the same way the universe expands space, by creating something new, not by claiming existing territory. Each new theory, each new observation, each new insight creates a bit more conceptual space in which we can operate. It doesn't displace old understanding so much as it supplements it, adding layers and nuance and connections we didn't see before. And just as cosmic expansion reveals the underlying unity of the universe, the fact that all of space is connected, all participating in the same grand stretching, intellectual expansion reveals connections between seemingly disparate phenomena. We discover that electricity and magnetism are two aspects of the same force. We realize that matter and energy are interchangeable. We understand that space and time are woven together into a single fabric. Each connection makes the universe simpler, more elegant, more unified. We started with hundreds of separate phenomena, each requiring its own explanation. Through the work of countless scientists, we've reduced them to a handful of fundamental forces and particles governed by a relatively small set of equations. The universe hasn't gotten simpler, it's still as complex and mysterious as ever, but our description of it has become more concise, more unified, more beautiful. And perhaps that's the ultimate answer to the question of what the universe is expanding into. It's expanding into our understanding. As our knowledge grows, the universe that exists in our collective consciousness becomes larger, richer, more detailed. We map more of cosmic space, measure more of cosmic time, discover more of cosmic complexity. The observable universe gets bigger with each new telescope, each new satellite, each new observation. Of course, this is just a metaphor. The universe doesn't actually expand into our understanding. It expands regardless of whether anyone is there to understand it or not. But from our perspective, From the human perspective, the growth of knowledge parallels the growth of space. Both are processes of expansion, of creation, of bringing new things into existence. And both challenge us to think beyond our limitations. The universe challenges our spatial intuitions, asking us to comprehend expansion without an outside. Our quest for knowledge challenges our intellectual intuitions, asking us to accept truths that seem impossible, to work with concepts that defy visualization, to trust mathematics and observations even when they lead to uncomfortable conclusions. This is the essence of the scientific enterprise, following the evidence wherever it leads, even when, especially when, it leads somewhere unexpected. The expansion of the universe without an outside is exactly the kind of conclusion that makes people uncomfortable. It violates our intuitions. It doesn't fit our everyday experience. It seems to defy common sense. But it's true as anything in science can be. We've measured it. We've observed it. We've built theoretical frameworks that explain it and make predictions that have been verified by further observations. The expansion of space is not speculation or philosophy. It's established fact, supported by mountains of evidence from multiple independent sources. And that fact is telling us something profound about the nature of reality. It's telling us that space is not what we thought it was. It's not a passive container, an inert background against which events unfold. It's an active, dynamic component of the universe, capable of changing and evolving in ways that affect everything within it. This realization opens up new possibilities, new questions, new areas of investigation. If space can expand, can it also contract? Can it twist and tangle? Can it develop structure and complexity of its own? These aren't just idle speculations, they're active areas of research, with physicists exploring exotic solutions to Einstein's equations that involve wormholes, closed time-like curves, and other mind-bending possibilities. Some of these solutions are probably just mathematical curiosities, with no counterpart in physical reality, but others might be real. The universe has surprised us before. It might surprise us again. Perhaps there are regions where space is contracting rather than expanding. Perhaps there are bubbles of different kinds of space with different properties and different laws. Perhaps the fabric of space-time is more varied and interesting than we currently realize. We don't know. We're still exploring, still discovering, still pushing at the boundaries of knowledge. And that's exactly as it should be. Because a universe that we fully understood would be a universe without mystery, without wonder, without the thrill of discovery. The fact that there are still questions to ask, still phenomena to explain, still mysteries to unravel, that's what makes science exciting. And the expansion of space is one of the grandest mysteries of all. Not because we don't understand it, we do, at least to some degree, but because it points towards something deeper. The fact that space can expand suggests that it's not fundamental, that it might emerge from something more basic. Physicists are actively exploring this possibility, trying to understand how space-time might arise from quantum entanglement or other quantum information processes. If they succeed, if we eventually develop a theory that explains space and time as emergent phenomena rather than fundamental entities, it will revolutionize our understanding of reality even more dramatically than general relativity did. It will answer the question of what the universe is expanding into in a completely unexpected way, by showing that the expansion isn't really expansion at all, but something else entirely, some process we don't yet have words for because we've never encountered anything like it before. This is how progress happens in physics. Not through small, incremental improvements to existing theories, but through conceptual revolutions that completely reframe how we think about fundamental questions. The expansion of space once seemed impossible, a violation of common sense. Now it's established fact. Perhaps what seems impossible today, emergence of space-time from quantum information, for instance, will be established fact tomorrow. Or perhaps not. Perhaps space and time really are fundamental, and the expansion is exactly what it appears to be: the creation of new space, the growth of the cosmic fabric, the inexorable stretching that will continue until the universe becomes infinitely large and infinitely empty. We don't know which picture is correct. Both have their advocates, both have strengths and weaknesses. What we do know is that the universe keeps expanding, keeps evolving, keeps becoming more than it was. And we keep observing, keeps measuring, keep trying to understand. The conversation between humanity and cosmos continues, with each question answered leading to new questions, each mystery solved revealing deeper mysteries. This is the human condition, to be creatures of finite lifespans in an infinite cosmos, beings of limited understanding confronting unlimited complexity, minds shaped by evolution for survival on Earth trying to comprehend the nature of existence itself. It's absurd. It's impossible. It's magnificent. And somehow, despite all the limitations and challenges, we're making progress. We're learning. We're growing. We're expanding our understanding in parallel with the expansion of space, as though there's some deep connection between the physical growth of the universe and the intellectual growth of the beings within it. Maybe there is. Maybe the universe produces observers, conscious beings capable of wondering about their origins, precisely because it's the kind of universe that expands and evolves and creates complexity. Maybe consciousness is the inevitable outcome of a cosmos with the right properties, the right laws, the right initial conditions. Maybe we're not an accident, but a natural consequence of cosmic evolution. Or maybe we're vanishingly rare, a cosmic fluke that happened once in this universe and might never happen again. Maybe consciousness requires such an unlikely combination of circumstances that we're alone in the observable universe, the only witnesses to the grand cosmic drama unfolding around us.
We don't know. We're searching for life beyond Earth, listening for signals from other civilizations, looking for biosignatures on distant planets. So far, we've found nothing. The universe seems empty, devoid of other minds, other observers, other beings asking the same questions we're asking. But the search continues. Because even if we're alone, even if consciousness is rare to the point of uniqueness, we're still here. We're still observing, still wondering, still trying to understand. And the universe we're trying to understand is expanding, creating more space with each passing moment, growing larger and more diffuse as dark energy pushes galaxies apart. This expansion is our cosmic inheritance. It shaped the universe we inhabit, created the conditions for our existence, and will determine our ultimate fate. Understanding it isn't optional. It's essential to understanding ourselves, our place in the cosmos, our connection to everything that is and was and will be. And the key insight, the crucial understanding that makes sense of cosmic expansion, is this: the universe doesn't need an outside. It is complete in itself. It is all of space, all of time, all of existence. When it expands, it's not growing into some pre-existing void. It's creating space itself, bringing new distance into being, increasing the volume of reality from within. This is strange. This is counterintuitive. This challenges every assumption we bring from everyday experience. But it's true. And embracing this truth, accepting it fully, despite its strangeness, is the first step toward understanding the cosmos we inhabit. From there, everything else follows. The Big Bang as a moment when all of space was compressed to a point, not a point in space, but a point that was space. The expansion as a stretching of that space in all directions simultaneously, with no center and no edge. The acceleration as a consequence of dark energy, a property of space itself that causes expansion to speed up rather than slow down. all of these concepts fit together into a coherent picture, a scientific understanding of cosmic evolution that's been tested and verified through countless observations. It's not complete. There's still gaps, still mysteries, still phenomena we don't understand, but it's solid. It's reliable. It's the best description of cosmic reality we've ever achieved. And it's telling us that the universe is far stranger than we ever imagined. That reality doesn't conform to our intuitions. That existence itself is more wonderful, more mysterious, more beautiful than any story we could have invented. This is the universe we live in. This is the cosmos we're part of. And understanding it, really understanding it, not just memorizing facts, but grasping the deep conceptual foundations, requires letting go of our assumptions and accepting that space can expand without expanding into anything. It requires accepting that the universe is self-contained, self-sufficient, requiring nothing beyond itself to exist or evolve or create. It requires recognizing that we're not outside observers looking at the cosmos from some external vantage point, but participants in the cosmic drama, made of the same stuff as stars and galaxies, subject to the same laws, part of the same expanding fabric. We are the universe experiencing itself. When we observe cosmic expansion, the universe is observing its own growth. When we wonder what it's expanding into, the universe is questioning its own nature. When we develop theories and make observations and slowly piece together a coherent picture of cosmic evolution, the universe is coming to understand itself through us. This isn't mysticism or poetry, it's literal truth. We are made of atoms forged in stars, organized by evolution into patterns capable of thought and consciousness. We are matter that has become aware, stardust that has learned to wonder about stars. The universe gave rise to us through billions of years of cosmic and biological evolution, and now we're trying to understand the process that created us. It's a remarkable situation. And it means that the question, what is the universe expanding into, isn't just a question about physics or cosmology. It's a question about ourselves, about consciousness, about the relationship between mind and cosmos. Because in asking this question, we're probing the limits of human understanding, testing whether our brains can grasp truths that transcend everyday experience. And the answer we found, that the universe expands without expanding into anything, is a testament to human capability. It shows that we can understand more than we might think possible, that we can grasp concepts that defy intuition, that we can build mathematical frameworks that capture truths our senses never directly perceive. This is the glory of human intellect, the ability to transcend immediate experience, to reason about things beyond the reach of our senses, to construct theories that explain phenomena occurring on scales of billions of light years and billions of years. We're finite beings grasping at infinity, mortal creatures contemplating eternity, products of evolution, understanding cosmic evolution. It's hubris, perhaps, to think we can understand the universe, but it's also our greatest achievement. Because despite all the limitations, despite our tiny size and brief lifespans, despite our evolutionary origins on a small planet orbiting an ordinary star, despite all of this, we've managed to figure out how the cosmos works. Not completely, not perfectly, but substantially, meaningfully. We've mapped the large-scale structure of the universe. We've measured its age and size. We've traced its history from the first moments after the Big Bang to the present day. We've predicted its future evolution. And we've done all of this using nothing but careful observation, clever reasoning, and the willingness to follow the evidence wherever it leads. The expansion of space without and outside is just one example of this success. It's a concept that seems impossible at first encounter, that violates every intuition we have about how expansion should work. But through patient observation and theoretical development, we've come to understand it. We've grasped how space itself can grow, how distance can increase without objects moving, how the universe can be complete in itself without requiring an external context. This understanding didn't come easily. It took decades of work by countless scientists, astronomers, mathematicians, and theorists. It demanded that people set aside their preconceptions and accept conclusions that seemed absurd. But they did it. We did it. Humanity collectively figured it out. And in doing so, we expanded our own horizons as much as the universe expands its own space. We grew intellectually, conceptually, philosophically. We became beings capable of grasping cosmic truths that our ancestors couldn't have even imagined.
And the journey continues, because every answer raises new questions. Every mystery solved reveals deeper mysteries. The universe keeps expanding, both literally and metaphorically. There's always more to learn, more to discover, more to understand. So when you look up at the night sky, when you see those distant stars and think about the galaxies beyond them, remember, you're looking at an expanding universe, one that's creating space itself with each passing moment. You're seeing light that's been stretched by cosmic expansion, reddened by the growth of space as it traveled through the universe to reach your eyes. And remember, too, that you're part of this expansion, not in any mystical sense, but in a completely literal one. The space around you, between you and those stars, is participating in the same expansion as the space between galaxies. It's all one fabric, one cosmos, one unified whole expanding together. You don't expand with it, because the forces holding you together are stronger than the expansion. But the expansion is still there, still happening, still stretching the fabric of space-time in which you exist. You're a localized structure in an expanding universe, an island of complexity in a growing ocean of space. And you're also an observer, a consciousness, a mind capable of understanding the expansion and wondering about its nature. You're the universe aware of itself, asking questions about its own growth, seeking to understand what it means to expand without an outside. The answer to that question, the deep, philosophical, meaningful answer, is that the universe is complete. It is all there is. And its expansion is simply what happens when you have a universe governed by general relativity with the particular distribution of matter and energy that ours has. It's not expanding into anything because there's nothing for it to expand into. It is creation itself, the ongoing genesis of space and time and existence. And we are part of that creation. We are witnesses to it, participants in it, products of it. The expansion that puzzles us is the same expansion that made us possible. The mystery we're trying to solve is the mystery of our own origins, our own nature, our own place in the grand cosmic scheme. So perhaps the final answer to what is the universe expanding into is simply into the future, into whatever comes next, into the endless unfolding of cosmic time, the eternal evolution of space and matter and energy, the ongoing story of existence itself. And we get to be part of that story, at least for a brief moment. We get to observe and wonder and understand, at least partially. We get to ask the big questions and sometimes find answers. We get to expand our understanding along with the expansion of space, growing in knowledge as the universe grows in size. This is our cosmic privilege. This is our place in the universe,
Not at the center, there is no center. Not as the purpose, there may be no purpose. But as observers, as understanders, as conscious beings who can look at the expanding cosmos and marvel at its strangeness and beauty. The universe is expanding. Space is growing. Distance is increasing. And somewhere within this vast, ancient, evolving cosmos, on a small planet orbiting an ordinary star, beings made of stardust have figured out that the expansion doesn't need an outside, that creation can happen from within, that existence is self-sufficient. It's a remarkable realization, and it's just one small piece of the much larger story we're still writing, still discovering, still living. The story of the universe and everything in it, the story of expansion and evolution, the story of how something came from nothing, how complexity emerged from simplicity, how consciousness arose from matter.